Everyone, welcome back to the class of Math 1450, Math and the Modern World. Last time we talked about the equations. This time it is for the inequalities. Clearly, when you have two expressions, when they are not the same or they are not equal, and we have an inequality. And specifically in terms of inequality, I want to review a little bit for the inequality signs. Four of them, this is less than. Keep in mind this really means strictly less than. Okay. The next one here, it is greater than. It means strictly greater than. And this notation, it is less than or equal to. The equal part is included. Okay. And the last one, it is greater than or equal to. And again, the equal part, it is included. And it is very common, like in a very simple case, we have an expression like x greater than 3, which really means any real numbers greater than 3. But the 3 number itself, it is not included. Okay. And also, sometimes it is somewhat, it is more convenient. Well, it depends. Like in this case, it's not necessarily true, but we can write an inequality using an interval notation, and 3 all the way to infinity. This sign, if you are not familiar with this sign, from now on we are going to see this notation a lot. It is infinity. It is the infinity symbol. Okay. And so this is the infinity symbol. And when we have inequality, we also can represent the situation on a single real number line. So this is roughly, well, it is precisely how the graph would look like. It might be hard for you to see on the screen, but you can check with the notes or on the textbook. You see this little portion, it is highlighted. It is highlighted, okay. And also at this particular point 3, there is this round parentheses, which really means the actual number 3, it is not included. Actual number 3, the number 3, it is not included because it is strictly greater than. Strictly greater than, okay. And also, similarly, we may have the situation like the next inequality, x is less than or equal to 1. And clearly, in this case, 1 is included. And we can write this inequality using the infinity notation too. But you see, this time we are talking about all numbers less than 1. 1 is included. First of all, to indicate 1 is included, you see this side of parentheses, we are having a square bracket instead of round parentheses. Round parentheses, we want to say the number itself, the number by the round parentheses itself is not included. With the square bracket by the number, we want to say number itself is included. We are talking about all the numbers less than 1. So it goes from, well, could be 0, could be -1, -100, could go all the way to infinity. So we put this as a negative infinity, okay. Negative infinity. Another small thing to remind here is, the parentheses for the infinity, because you really want to understand either way, infinity or negative infinity. It's not an actual number, so you really cannot. It does not make sense if you have infinity included, okay. So we always have the round parentheses comes with the infinity sign, either positive infinity or negative infinity. By the way, I did say positive infinity, but most likely you will not see positive infinity at all, because, without a negative sign, it simply it is plus, okay. It is positive. And so this is the interval notation for the inequality x less than or equal to 1. 1 is included. And also you look at the graph, you see we are having all the numbers less than 1. And because 1 is included, so this time in the end, okay, this is the right end of the interval, and we have 1 included. Instead of using the round parentheses, we are having the square brackets there, square brackets. And somewhat we have tried to cover all the situations. Literally, I copied all the graphs from the textbook, not just for this part of notes, and you need most of the notes are directly from the textbook. Okay, basically this will hopefully explain very well not all kinds of the basic inequalities we need to handle. Round parentheses, square brackets. Can you tell the difference when to use round parentheses, when to use square brackets? Okay, when you have something strictly greater than or strictly less than, use round parentheses. When the equality part is included, okay, the equation part, it is included, you use the square brackets. Use the square brackets, okay. And as I'm saying, these are the basic cases of the inequality. Sometimes we have situations a little more complicated. And so this is the example of the case. We have a compound inequality, x strictly greater than -3 and x strictly less than 4. So if you look at the graph, you see we are having the numbers running from -3 to +4. And either way, the left and the right end are not included. So for both endpoints, we are having the round parentheses. We are having the round parentheses there. Does it make sense to you? A compound inequality, okay. We are having a line segment in between. And you see, when we say a compound inequality, it really means at least 2 inequalities. You have to write out 2 of them, right, in this case. And indeed, somewhat in a better way, we can use the interval notation, okay, running from -3 to 4. So this is the interval notation, okay. And inequality and the equations, somewhat, I would say they come together. And first of all, we have the equation, then we have the inequality. And then usually for equations, we have solutions. And for inequalities, we also have solutions. But the way to solve the equations, somewhat it is a little easier. Remember, we have the addition principle, and the multiplication principle. And now for the inequalities, basically the addition principle still stays the same, which really means you can add both sides of the inequality by a same number. The inequality is still true. But for the multiplication principle, you want to be a little more careful, okay? When you multiply both sides of the inequality by a positive number, multiply both sides of the inequality by a positive number, the inequality sign stays the same. And then when you multiply both sides of the inequality by a negative number, you want to know the inequality sign will have to be changed, will have to be flipped. Okay, and the inequality sign reverses, which really means if it's less than, you're going to change it to greater than. If it is greater than, change to less than. Okay, this is true when you multiply both sides of the inequality by a negative number. So let's look at the next example. We are having example 24. Okay. This is the actual inequality we want to solve for y. So we follow the way like we did. First, what I really did, I have the like terms, moving the like terms to the same side. And specifically this time, I'm talking about terms with the unknown notation y. And adding -11y to both sides. And then adding to the left side, the result, it is -5y. And certainly the right hand side, when I add this negative term to both sides, this negative term will cancel the original term over here, okay? So now we are reaching to the point, the inequality in I would say, somewhat in one of those basic fashions, but we don't have this y yet. Okay, y is not solved yet. So to single out y, what I did next, I simply multiply both sides by -1/5. So left hand side I have y. Right hand side I have -17/5. I multiply this inequality, the left and the right, both sides by -1/5, and I get this. And then I hope you see in the middle, I did change the sign of the inequality, right? Change the direction of the inequality from less than equal to greater than equal to. Because what I did, I multiplied by -1/5. -1/5, okay. This is only true when you multiply a negative number to both sides of the inequality. So, and then for the graph part, it is pretty much the same thing like we did it before. And as the final answer, we are having all the numbers greater than or equal to -17/5. This is how the graph line segment would look like. Half line, it is a half line. And besides, the left end is included because we do have the equal notation part. And this is the interval. This is the interval, okay. And there are two examples about applications of inequality. I'm going to let you to read, and if you have any questions, let me know. These are pretty much very straightforward calculations. And so this is the lecture part of section 5.3 inequalities. So far for chapter 5, we started a discussion on expressions. Then we have equations, and this time it is about inequalities. Somewhat there are similarities, like the addition principle and part of the multiplication principle. But again, you may want to know, for the multiplication principle, there are two situations, there are two cases. For inequality, when you multiply both sides of inequality by a negative number, you are going to change the direction of the inequality notation. Okay, inequality notation. Section 5.3 inequalities. Thank you very much for watching.